Hi, and thanks for joining us for another ITPro live session. My name's Adam Shepherd, Reviews and Community Editor for ITPro, and I'll be your moderator for this Q&A. We've heard a lot about transformational technology this week. We've talked about everything from 5G and IoT to remote working and the cloud tools that enable it. But there's another area of technology that is transforming businesses all over the world: edge computing. Here to talk to me today about edge computing, hyperconverged infrastructure, and how the two can combine to support businesses is Jeff Reedy, CEO of Scale Computing. Jeff, thank you for joining me.
Thank you, Adam. Glad to be here.
So, before we dive into the questions, I wonder if you can tell us a little bit about Scale Computing, what it does, and what it offers to customers.
Sure. So Scale has been around for about 13 years. We provide kind of a comprehensive IT infrastructure solution that runs applications. So you can think of Scale as being a alternative to or augment to traditional data center infrastructure. So by that I mean VMware most likely, or Hyper-V on the virtualization side. Obviously storage, networking, etc. The thing that's different about Scale is that we combine all those technologies into one, eliminate a lot of vendor silos and different costs, and ultimately kind of wrap the entire environment with self-healing technology. We started really focused on smaller IT organizations. So think kind of mid-market IT, even SMB IT. We would look for environments where you had 1 to 5 folks on the IT side. And the idea was that this automation technology, the self-healing technology we developed, is cool for everybody, but it is most useful if you have a small IT staff. Because you just have fewer hands. And so this became an extra set of eyes, ears, and hands to manage your data center. What we've seen happen over, again, a decade plus of doing this is that those kind of SMB mid-market technologies, the technologies needed for those small IT staff, environments now apply directly to this new world of edge computing, where you often have 0 IT people on site. And so you need many of those same technologies.
So we've heard a little bit about edge computing over the course of this week. We spoke about it briefly in the previous session with Justin Cutler on-premise and the value thereof. But tell us a little bit more about what edge computing is to you and why you find it so transformational.
Yeah, sure. So, there's a lot of different definitions for edge computing. I think that the best definition that I've heard is that edge computing represents anywhere you are going to run mission critical applications outside of the data center. And that phrase "outside the data center" is really the key. So that could mean in the type of a lot of edge computing use cases. People like to talk about the hottest, coolest new technology. So you're thinking about things like 5G, and at the base of a cell phone tower, they're deploying effectively racks of hardware. And those are sort of mini data centers, very near, obviously trying to get the data center nearest to where data is being generated. And that's an edge computing use case. But likewise, this could be, completely on premises. I mean, the farthest reaches of the edge, where you're talking about infrastructure that exists inside of a grocery store, for example, or a restaurant, or in transportation on a shipping ship or a truck, things like that. So again, anywhere where applications are going to run, and the applicability is pretty broad, right? I think that the thing that most people immediately think about is data collection in a hybrid cloud. And that's certainly a fabulous use case, where you're collecting so much data so rapidly at these edge locations that you need to process that data locally, and then perhaps send metadata and so forth back to the cloud. I think the classic example that a lot of us in the edge industry use is if you're driving a Tesla or some other self-driving car, and an animal a deer runs out in front of the road, you don't want the Tesla asking Google if it should stop, right? In fact, there's a physics problem there, which is if the decision-making process is in San Francisco and you're driving in New York, and that's 2,000 miles away, a perfect packet of data round trip to send information to the San Francisco data center and get it back. If you're driving 70 miles an hour, you will have gone 16 or 17 feet in that period of time, and you would have already hit the animal before the car reacted. And so clearly there's a situation where you want decisions made locally. And, that's obviously a little bit of an illustrative example, but there's lots of reasons why you might want to do that. Speed and latency and so forth. There are also very practical reasons why you need to make these sorts of decisions locally. Certainly, and increasingly so, privacy is a concern, and you don't want anything that could even remotely be personally identifiable information leaving the premises where that information was gathered. And so, we're seeing now in the post-coronavirus world, folks wanting to install video cameras that check, are people wearing face masks, thermal cameras checking temperatures of customers in stores. For obvious reasons, you don't want that data traversing all over the internet for various security risks. And so you need to make certain decisions in the store. Now, ultimately, if there's an alert, somebody's not wearing a mask and they should, right, that might be a piece of information that moves into the cloud or something like that. So, ultimately, with all these different use cases, I personally see edge computing as the next major turn in IT infrastructure. So if you roll the clock way back to mainframes, mainframes were a centralized IT type of environment. That era, you could argue where the beginning and end, but I would argue that the peak of the mainframe area was about a 20-year period. So you got to the 1980s, and then you had the PC server, first just the IBM PC. Ultimately, PCs became PC servers, and you moved from that centralized environment into a more distributed IT type of architecture. And we all did sort of on-prem client servers rather, again, for about a 20-year period. Into the 2000s, and then sort of you had the rise of the regional data center, and when you think regional data centers, you're thinking racks of gear and VMware and so forth in that environment. And here we are 20 years later now talking about a different kind of architecture, where you're talking again getting even further out to the edge on different systems. Some of these systems are servers that are not traditional looking servers. I mean, you can see on the camera, this is a device called an Intel NUC, which I'm sure many in the audience are familiar with. But this thing that fits in the palm of my hand is something that, that at scale we use as servers for our customers. And so, on one of these ships, for example, that's out at sea, we'll run one or more of those in a cluster, and that becomes the infrastructure, right? There's no need for a traditional server. And even more so, right, if you're thinking, oh, what about the infrastructure that's in the back of a coffee shop, where, again, maybe I'm running this application to see if customers are getting sick. There is no rack in the back of that coffee shop, and certainly the cost of deploying traditional IT infrastructure across tens of thousands of retail locations is prohibitive. No IT people, and so form factor and things make a big difference. So I think there's going to be a lot more of that. Ultimately, this does of course tie back into the cloud, but I view edge computing as we're at the beginning of this next big turn in IT infrastructure that I imagine will last another 20 years.
So you've mentioned a few use cases, things like trucking and things like retail, logistics, that kind of thing. which may come as a surprise to some viewers who associate the concept of edge computing with things like offshore oil rigs or wind farms,
Hmm.
remote factories, that kind of thing. Uh, what other kind of use cases are there for edge computing within other industries that people might not expect? Perhaps things that aren't limited by their remoteness or by their level of internet access.
Sure. And I think, those use cases that sort of immediately come to mind as you described are, of course, completely accurate, edge computing use cases. And we see that all the time. But increasingly, we see what I would consider more traditional companies deploying edge computing for one reason or another. A retail is a great example. So, we talked a little bit about the coffee shop or the grocery store, and I can think of many of my customers, for example, in the grocery space. The challenge that they're faced with is that they have a mix of applications, and I think this applies to almost any commercial enterprise today, which is that some of those applications are brand new. Maybe they're containerized applications, maybe they're purpose built for the edge, and so forth. But they also have a 25-year-old point of sale system that they have, runs on, Windows 2000. And they haven't upgraded it yet, and they're probably a way off from updating it. And one of the challenges that these organizations face is that they want to deploy these new applications. They may need to deploy more and more infrastructure at the edge. Again, video cameras being a very common use case, but even beyond that, we're seeing a convergence of IT and what would be traditional OT technologies. So, temperature sensors and other types of sensors collecting data previously may have gone through a proprietary gateway from a company like Honeywell or Schneider Electric or Siemens or these types of folks. But now seeing a convergence of that infrastructure and traditional IT infrastructure. The reason is you only want to run one set of IT infrastructure, one set of infrastructure at all at these edge locations. It's very difficult, right? You don't want a siloed infrastructure for cameras and a siloed infrastructure for sensors and a siloed infrastructure for traditional applications, whether new or legacy. And so, the opportunity, like if what I see companies doing is if they're going to deploy new infrastructure because they have edge use cases, they're also wanting that infrastructure to kind of span old stuff as well. So again, I see it in retail, I see it in banking and in healthcare. And of course, when you think healthcare is maybe a good example, when you think healthcare, but what comes to mind immediately is inevitably, the large hospital. And of course, there's a very sophisticated IT infrastructure at that large hospital. But what happens at the lab and the clinic and the individual physicians' offices and things like that? And these, are often affiliated with some kind of a broader healthcare network, but there's no IT folks on site, right? And so the um, the technical challenges of the edge are significant, and probably the best way to summarize those challenges is to think about what are your biggest costs in IT traditionally, right? And I would argue, and I think most would probably agree with me, that your two biggest costs in IT are downtime and people, right? And we all like to, look at all the spreadsheets and say, well, this is how much this server costs and this is how much this software costs. But ultimately, downtime is significant. And when you go to these edge locations, like I was describing in a retailer, for example, if the point of sale system is down, that those lost dollars can be measured by the second. If a camera is down in a critical security environment, you can measure that the cost of that downtime. And so, downtime becomes exponentially more difficult out at the edge because you don't have the people, the other side of that equation, on site to jump in and fix things. Right in the data center, stuff crashes, dies, a hard drive fails. somebody goes in, pulls out one of the spare hard drives and replaces it in that, that RAID array or what have you. If this is happening in the back of a grocery store where there's no IT folks, that is a non-trivial exercise. And then thinking about, I have a new application I want to deploy. Again, maybe we're rolling out these thermal cameras and there's a new application for monitoring temperature. If I have to do that 19,000 times across a lot of retail locations, again, that is a very non-trivial exercise. So the biggest thing, going back to that original definition that I gave of mission critical applications outside the data center, the real challenge with the edge is that there's a lot of things we assume in a data center environment that just don't exist at the edge. People, reliable power, reliable internet. And so, we're seeing that same type of infrastructure that works great on the oil rig turns out works great in a retail environment, in a bank, in a physician's office.
So where does hyperconverged infrastructure fit into this, and how do both HCI and Edge combine to play a part in a modern hybrid cloud architecture?
Sure. So, HCI at its core, right, was about, converging a siloed storage platform into what was a siloed compute platform, and merging those elements together, hence the hyper-converged name to begin with. And so hyperconvergence, by definition, simplifies IT infrastructure. As I was just describing, simplification is sort of now becomes the killer app, or the killer feature to make the edge work. And again, you can fall into a lot of traps by making assumptions about the edge where those things don't exist in the data center. And so what we think about is not just the traditional storage plus compute side of hyperconvergence, but we think about, well, what else can be converged? Because again, if you're going to deploy that infrastructure on something like this, right, there's no SAN, there's no, it maybe not even a network switch, right? So you're starting to employ software-defined networking technologies into the same stack, the virtualization and container technology into the same stack, storage and compute, et cetera. And ultimately, that has to be automated in such a way that you can get high availability at that edge location, knowing that there is no IT person on site, right? Even the exercise which says, okay, this system needs to be rebooted. Okay, well, you may now be trying to get on the phone and talk to the barista at the coffee shop and have them reboot a system, right? That's not a place that any IT director wants to be. So, so it's sort of starting with that concept of hyperconvergence in storage and compute and extending it beyond that. Ultimately, where we are certainly taking folks, because it's where I think things are going, is this hybrid cloud and edge infrastructure. So deploy these systems. If you have one location or 5 locations, you can certainly individually manage those. But as you see environments where there might be hundreds, thousands, tens of thousands of locations that have to be managed, you start needing to look to cloud-based portal type management. So some of the paradigms that have become fairly familiar to us in IT, such as a cloud portal to manage Wi-Fi access points, as an example, right? Taking that paradigm but extending it to the entire infrastructure, being able to, with a single instruction, deploy a new application or update an application across all the sites, some of the sites, et cetera. And really automation becomes the key. So I think that that concept of hyperconvergence, was the seeds that led to kind of this idea of broader automation, and ultimately, being able to ship a device to an edge location, have somebody simply plug it in and turn it on, and then that device has to configure itself, right? So it's going to communicate back to a cloud portal. It's going to cluster itself, create the environment, and then download its applications, and can be completely managed. And importantly, and you made this point when you're thinking about whether it's the extreme remote edge, like those oil rigs, or that coffee shop, these systems may go offline. In this case, offline, I mean disconnected from the internet. So that problem that the over-the-road truck has, where the internet connection is intermittent, we have found that in retail, in SMB in general, in kind of mid-market type environments, internet is a fairly unreliable component of the data center. You may have a cable modem connection to the internet, and when the cable company needs to reboot something, it just does. And you need that resiliency in place to handle those sorts of things. So again, taking that HCI concept, extending it through full automation, and effectively enabling centralized control of all these locations. Again, whether it's one or thousands, but following that paradigm that we've all started to move down, which is cloud management of edge type infrastructure.
So this concept of almost plug and play infrastructure and stuff that's very easy to centrally manage, to automate, as you said, with kind of rules-based and policy-based tools. Does this remove a lot of the complexity for organizations who maybe, as you mentioned previously, don't have a large, dedicated, or particularly technically skilled IT department to access some of the more transformational benefits offered by modern technology, but that may be slightly out of reach to less digitally minded organizations?
Yeah, I think that's exactly right. Right. So, and if people look at the history of scale, as I talked about a little bit in the beginning, our experience with SMB and mid-market type customers is what pulled us directly into edge computing. What happened is that we had very large organizations that were global 2000 distributed enterprises looking at us and saying, okay, we know that your technology is there to help automate things for these small IT staff. I am a grocery store. I have 8,000 stores, and I'm a global enterprise. But in reality, I'm a global enterprise made up of 8,000 SMB type locations, right? And so that that becomes the key piece of all of that technology. And it's more than just automation, right? Because in the end, again, one of those two big costs in IT were people. And so automation obviously lowers the number of folks that you need, but automation also means, well, how easy is it to implement some of these things, to roll out that new application, or to update something that is already on site. We like to think about making these sort of professional IT infrastructure environments smartphone easy, right? So think of just the break fix scenario. A device dies, right, on premises. If you've got three of these little guys in a cluster, the application's still running, but the dead one does need to be replaced. And how is that going to happen? If you have to roll a truck, as the term goes, and send an IT person on site to physically touch and play with that system, that's extremely expensive, right? And one of the biggest costs that a lot of organizations who deploy things or need to deploy things at the edge have is that service contract with IBM Global Services or whoever it might be, to roll that truck and have somebody on site within 2 hours or 4 hours or what have you. In this case, when I say go smartphone easy, what I'm talking about is, if you have if you break your phone, right, what's likely to happen is if you call Apple or you call Samsung, they'll send you a replacement phone with a box and a return label, and all you do is put your dead phone in the box, bring up the new phone, and it will re-download and sort of put all your applications back on it, such that somebody who, obviously phones are used by everyone, somebody who's not in IT at all is quite capable of putting a dead phone in a box and turning on the new phone. And that's where we're going and are delivering with IT infrastructure. One of these devices dies, the new one shows up. All the person on site has to do is plug it in and put the old one in a box, right? And that can be done literally by the barista at the coffee shop, and eliminate that that need for having on-site, on-premises IT staff. When I mentioned a little bit ago about don't fall into the trap of assuming the things that are at the data center. So at the data center, if spinning up an application or making a configuration change takes 45 seconds, you would consider that zero time, right? It doesn't take any time, right? It make a type a few commands and that configuration has changed. If you then have to multiply those 45 seconds times 10,000 locations, it becomes an insurmountable challenge, right? And so it's wildly different. And being able to use automation to solve that problem is really critical, and effectively enable the infrastructure to run in the absence of on-prem IT staff.
So, with that in mind, do you see a future where hyperconverged infrastructure and edge computing can effectively allow organizations to create a totally distributed data center effectively, doing away with data centers as we traditionally know them and running their entire IT stack through these remote edge computing locations networked together?
Yeah, absolutely, and I see it happening already with certainly with our customers, and I would presume with others who are embracing edge computing. Um, if you have infrastructure at the farthest edge where data is being generated, and you can run applications safely there and make those applications highly available, and you also have the cloud where you can gather the resources of the cloud. If certainly if you need the power of 10,000 GPUs, you're not going to put that in the grocery store. If you've got that in the cloud, if you need the power of 2 GPUs, you can put that in the grocery store, right? So what a hybrid between edge computing and the cloud enables is that you just can run the application wherever it makes the most sense. And certainly many applications will have different components that make sense to run in one location or the other. What I see happening, to the point of your question, is effectively an erosion of market share, if you want to call it that, but basically an erosion of applications running in that traditional regional data center, right? And that's where, when I was making the comment about these kind of 20-year turns in IT infrastructure, that's the one that's falling away, right? That doesn't mean the regional data center ever goes away completely. IBM still sells mainframes, right? There's use cases where these things make sense. But I think what you're going to see, just as over the last 10 years, we've seen applications, many applications that ran in the regional data center move to the cloud because it made more sense. You're going to see now another chunk of applications that ran in that regional data center move to the edge. And so that lowers the need for those regional data centers, and many customers will eliminate them entirely, right? Some customers eliminated all on-prem entirely and moved all cloud. What you're seeing now with new applications and more data collection and so forth, you're seeing the need for more compute power at the edge. But rather than put that in a data center, we're seeing that go all the way to the far edge, as I described.
So, how can HCI and edge computing help boost business resiliency, which is something that you've mentioned a number of times during our conversation?
Well, yeah, I think I think that the technologies at play that can really boost the resiliency are some of the things I talked about that go beyond, I suppose, the traditional definition of HCI and move into automation. So when you think about a drive failure in a traditional storage system, and it's a RAID 5, RAID 6, RAID 10, whatever the configuration is, you lose a drive and the data is still online, and you can replace that drive. So we're all very familiar with that. Certainly in most hyperconverged platforms, that still held true. And that also included the ability to perhaps lose an entire node in a cluster and have the rest of the cluster continue to run. Now, to make that work, what we and others certainly developed were technologies to literally reconfigure where applications were running, move applications from a failed physical device onto a still running device, doing that in real time to maximize uptime, et cetera. And then from there, we saw the integration of technologies like data replication over the WAN and backups and so forth, such that now you go from, if you lose a component, you have failover. If you lose an entire device, you have failover in that local cluster. And then what happens if you lose the entire site? Well, you can fail over those applications to another site and for disaster recovery and so forth. And then, again, what we're seeing here is the development of new technologies to allow things like this, what we call zero-touch deployment. And in my certainly biased opinion, zero-touch deployment is kind of the holy grail for edge computing. Again, because even the most trivial of tasks in the data center can quickly become impossible at the edge. So application management, deployment, integration with tools like Ansible for Ansible playbooks and so forth, and ultimately, you make the infrastructure itself kind of transparent. And I think what's critical is this applies not just to VMs as we think about it in the data center, but to containerized applications as well. It doesn't matter what form the application takes. You still need high availability for that application, and that can actually, in some ways, be even trickier in a containerized world where the containers themselves are unaware of the hardware that they're running on. And so these automation platforms, the way that some of our technology works is that we are looking for anomalies in the IT infrastructure stack, and those anomalies can be dropping packets over the network. But as we all know, the occasional drop packet doesn't mean the network is down. But the pattern of those drop packets may start to expose future problems, and being able to identify those problems and perhaps even take corrective action on those problems before disaster strikes is really the key. So keep the applications running, enable those applications to run without local IT presence, and make the management of the remote edge sites easy enough that you're not multiplying 45 seconds times 10,000 to do that simple task, but that task remains a 45-second task.
So are there any recent technologies that have accelerated the development of edge computing in particular, particularly developments that have made it perhaps more affordable or more accessible for some of the organizations that you've already mentioned, the retail organizations or ones outside the traditional, offshore model?
Yeah, it's a great question. I think that you always have these kind of trends in IT, and you think about at different points in history, the quote unquote bottleneck in a server moves around the CPU, the network, the storage, etc. And for a long time, right, it was the storage. The speed of the spinning disks was was the bottleneck, and we moved to SSDs. And that made everything much, much faster. But now you've got NVMe, and the latency goes down, to single-digit microseconds. And so as that happened, you then now the sort of the long pole in the tent, that bottleneck tends to be the WAN connection, right? That that 12 millisecond connection that you've got to Google that seems really fast is orders of magnitude slower than the 8 microsecond local storage connection. And so, that's one of the things that enables things to move to the edge. when you start to combine these different automation technologies together to get high availability through software, now you don't have to deliver that high availability through hardware, and that lowers the costs significantly, right? Again, in something, these little type devices, right? You could point to all sorts of single points of failure on the hardware side in this. It has a single NIC port, it has a single power supply, it has a single, and the one I'm holding here, a single NVMe drive. All of those things could fail and take the entire box offline. But if you've got a cluster of those and the software is handling how that works, that enables you to build in more usable compute power, usable storage, at a fraction of the cost of having, truly redundant hardware, right? You think of the old SAN with multiple controllers, and that way, if one controller failed, you had the other physical controller and things like that, radically changing that cost structure. Underpinning all of this, I will, just from a computer science geek sort of history, is that it is the advancement in CPU speeds that really enables a lot of this to happen, right? I mean, the reason that when you had distributed environments, client server environments, and you went from a client server to, okay, now we need a separate storage array and we need a separate device called a switch for networking. And underneath the hood, and anyone in IT knows this, you crack those devices open. I mean, they're x86 servers, right? That Cisco switch, that EMC SAN are, in fact, x86 servers. They're just dedicated to a particular task. And that's because you couldn't run those tasks on the same server that was processing applications. The CPU couldn't handle it. And so, and maybe the network and other things couldn't handle it as well. But think of that CPU. Well, now, right, and to think also at that same era, right, 1990s, you get a new laptop. How long did that laptop last before you needed to upgrade? Probably 12 to 18 months. And all of a sudden, you had the slowest laptop around. Now it's not uncommon that I see folks running laptops that are 10 years old, and it's still running the applications they need. So you have this extra compute power. That extra compute power, more cores, the multi-threading, all those different things enables you to do more of this processing on the same device. Fewer number of devices lowers your costs significantly, and all of that kind of wrapped in automation is what drives the ability to deploy these things at the edge. It's, in these little devices, like I showed you, it's quite possible to run tens of thousands of IOPS, in a traditional storage sense, on a little box like that Intel NUC, which just blows people away, right? It's probably faster than, most everything you are running in the data center in a traditional sense. So you can run the applications on less expensive hardware and use software to deliver the high availability and the automation.
Speaking of which, yesterday we were joined by Raspberry Pi founder Eben Upton, which was a great session. If any of our viewers haven't seen it, I encourage them to check them out. But the Raspberry Pi is something that I've seen touted a lot as a real silver bullet for edge computing in particular, because it allows organizations or even just individuals to quickly and cheaply prototype and test out edge computing applications. Have you seen edge computing deployed using these devices and devices like them? I know you've been showing off the Intel NUC quite heavily, which is a wonderful device, by the way.
Yeah, so we have, right? What's interesting, and I think this is where, again, just in my own experience, where the difference between what makes sense in the lab and what makes sense in practice can diverge, right? And by that I mean I in my own home here, right? Again, I'm a geek, so I have a couple of Raspberry Pis running various little things that I like to do at home, and that's when you're building something for a specific use case, and I'm like, okay, this application is going to run, that'll run fine on that ARM processor, right? No problem. The challenge is when you start getting out into existing environments, right? Again, that coffee shop, that grocery store with the 20-year-old Windows 2000 app, right? That doesn't run on the ARM processor, right? And so, what we're seeing are customers, and often, right, they may have explored running things on something like Raspberry Pi themselves, and the DevOps team can do that just fine, but they can't then bring in the legacy applications. And so that's where then we would see somebody favor maybe something like the Intel device, because it is x86 based. And I keep showing this because it's sitting on my desk, but the reality is, our platform will run all this stuff, right? Traditional servers, and if you're on an ocean going vessel, right, there is typically a rack of gear, and you can put traditional servers in there. But the flexibility of being able to run kind of any application, I think, is key. Now, as more containerized applications sort of become the norm, then more and more, I think, can you see those ARM-based systems work, and the price point becomes very appealing for that. But the transition period is challenging, right? We're talking about NVMe drives, and have to remember in the back of our heads, people still use tape from time to time for backup, right? So these things tend to last a long time. I won't name the customer, but I can tell you I have a customer which is running an OS2 application in production. So if they have not upgraded the OS2 Warp app to run on Windows or to run on Linux, it's probably a far cry to have them port that over to ARM in the short term. But if they're only deploying, a particular application, ARM would work great. Again, the price points become very appealing, and you just use the software to deliver the high availability and the resiliency.
So moving on to perhaps less niche technologies than the Raspberry Pi, or arguably more niche, what role will 5G and IoT have in the spread and development of edge computing and HCI? Are they technologies which will enable and fuel edge computing, or are they needed? Is edge computing needed before 5G and IoT can really start to deliver value?
Yeah, that's a very good question, and I wish I was clairvoyant enough to give you the known answer. I would argue that the edge computing piece is probably required to really capture the value of what those technologies can offer, right? So the value of 5G is a combination of bandwidth and latency between a wireless tower and a wireless device. But again, going back to that Tesla example, that doesn't change the speed between that cell phone tower and the data center, which becomes the bottleneck. And so to really get the value, you need that effectively, what many will call edge, I would call near edge data center, that base of the cell phone tower infrastructure to run. And you can think as this technology, let's just run down that example. So you have a bunch of cell phone towers, and at each cell phone tower, you have these mini unmanned data centers running infrastructure. You can see how an application, so say I have a technician that's mobile in a truck. They're utilizing 5G because whatever they do, they measure certain things at an oil field and multiple oil fields or what have you, and they're gathering all this data and communicating with the local cell tower. If that same technician goes to a different location, what you want is that application that was running at the base of cell tower 1 to migrate to the base of cell tower 2 in order to maintain that low latency. And when you can do that, that's when you're really going to capture the value of that low latency that 5G can deliver, right? If you can't move the application to be near where that 5G use case is, then you start to fall back on the general latency of the traditional network. So you've got that. On the IoT side, I think it's very similar, but what we're seeing is a very rapid explosion in the amount of data being generated because of IoT and needing to process that data at the edge. So I would argue in many use cases, IoT is sort of already going, right, and will continue. When you think of I won't name the customer, but I talked to a customer in oil and gas. So let's start with them and then see how this goes to the broader use case. But in oil and gas, and they are generating so much data at the oil rig in real time that it is physically impossible for them to send that data to the cloud. Not only would it probably bankrupt them to have that much bandwidth just is not available. And so they have to make decisions on that data locally. And then, of course, there's metadata and stuff that then goes back to the cloud. Well, that kind of industry is, at the forefront of IoT type, technology. Again, it's cost and value, right? If the oil rig blows up, that's pretty expensive. So you want to monitor things in real time, and that all makes sense. As you then move into, again, to the other extreme, the fast food restaurant and the retailer, where they're, generating all this data. And again, we're seeing, everyone knows, right, the widespread use of video cameras for things beyond basic surveillance, right? Data collection, counting, in retail, the applications that count the people in line and see, are people, smiling or frowning as they exit the store, right? These are the kinds of applications. They see massive amount of data and a massive amount of data into customers who traditionally probably didn't have that robust of a data center to begin with, right? So the same problem that oil and gas company who spends, inevitably hundreds of millions of dollars a year on IT, right, it now translates directly to the kinds of problems that the regional retailer faces. And again, what happens when that store loses internet connection and so forth. So, there's certainly, the edge computing is a key component of making IoT and 5G work. Of course, you can always use one independent of the other, but to really get the true value of what those technologies are, I think it requires this. And that's why, again, this becomes that foundational infrastructure for this next 20 years. We're just, I think, at the very, very beginning of where we're going to see edge go.
Well, on that note, I am afraid that brings us to the end of our session. Much as I would love to continue talking about this, we are unfortunately out of time, but I would like to say thank you very much, Jeff, for taking the time to join us this afternoon.
Thank you for having me. It was fun.